Today we're going to talk about inequalities. Main thing we need to get down on our notes is when we are writing these in interval form, you're going to need to know these different ways of writing. We're of course going to deal with inequalities, so we will have less than and greater than signs, as we're accustomed to seeing. And we will also have greater than, equal to, less than, equal to. What we need to know right off the bat is when we are dealing with less than or greater than signs, the two signs that do not have an equal sign, we are going to set the intervals up with parentheses. And when we have the equal sign, we are going to set them up with brackets. The lowest number will always be on the left side. The highest number is going to be on the right. Lowest here, highest there. And the thing we need to remember as well is we cannot be equal to infinity. So in any time we will deal with infinity, we need to use the parentheses. So we're going to spend most of our energy today dealing with solving these algebraically. We can graph these, and we'll show you how to do that on Desmos after we're done with this initial lesson. But the main thing we're going to touch on today is solving these equations. So first thing we need to do, we only have one variable here, so we're going to isolate it. We start by subtracting. I'm going to isolate the x in this case, so we subtract over 87 because it is a plus 87, and we have negative 4x is greater than 28. And we run into a skill that we should have known from Algebra 1, but we're going to see it again. In order to get the x by itself, we need to divide by negative 4. And then that is the skill that I'm referring to. Recall, when we divide by a negative number, again, by a negative number, we always have to flip the inequality. So 28 divided by negative 4, of course, is going to change the sign to negative, and it will be negative 7. So on the number line, this is going to be negative 7. And since it is not an equal sign, we will have a open circle, And since the number is less than 7, we will shade all values less than 7. And then we highlight the arrow there as well. And then the way we write this in interval notation. Well, if all numbers are going to be less than negative 7, then that means negative 7 will be our biggest number, but not including negative 7. So what we would do is, in this case right here, we would just type this in, but I'm going to just show you the interval notation. The interval notation would be not equal to negative 7 because we do not have an equal sign, but since that's our upper number, it's going on the right, and if it's going infinitely left, it would be negative infinity. So this is our inequality notation, and this is our interval notation. So as we take a look at this one, you see there's a lot of stuff going on. One reason I highlighted this is because of this distribution of a negative number. So we do need to distribute a negative 3. Now, a lot of people get confused because they see the multiplying by a negative, but we are not multiplying both sides by a negative, so we do not have an inequality flip here. What we have is just to do the math. So this would be negative 30t minus 15. We have a few like terms on the right side, so we're going to go ahead and put those together. Negative 3t, and then there's minus 9. So we're going to keep looking for values that we can combine. We still have these two on the left side. So this is negative 32t. Minus 15 is greater than or equal to 3t minus 9. So I'm going to gather all my t values to the left side and all the nons to the right side. So that would be the plus 3t moving to the other side. And while I'm at it, I'm going to go ahead and move the negative 15 to join the negative 9 with a plus sign. You might want to draw a little line to remind yourself to keep balance on both sides. So we end up with negative 29t We haven't done anything to flip the inequality, so we're going to leave it alone. And we add 15 to 9 would give us a positive 6. Now we are going to do the division by a negative number. We divide by negative 29, excuse me. And since we divided by a negative number, we do need to flip our inequality. So this is no longer a greater than or equal to sign. It is now a less than or equal to sign. 6 over 29 does not reduce, so this will be the answer that we use. So here we have an absolute value inequality. Once again, we will go back and show you. We'll do all of these in a calculator because we can do these very quickly. But we're going to solve this algebraically. The main thing you need to remember about an absolute value is there are two solutions unless it's equal to 0. So we are going to have to set up two equations. Regardless of what we do, we always isolate the absolute value bar. So we're going to remove the things around it. And we have to do it in the reverse order of operations. So we need to move our 7 to the other side. So we add 7, which leaves us with negative 4 times the absolute value of x plus 5. And then this is negative 8. When you get the bars by themselves, you got to ask yourself the question, because remember, absolute values have to be positive. So we will keep that in mind. But when you see negative signs on the opposite side of the absolute value, you should have a red flag going up. So do not distribute. First of all, you cannot distribute inside of an absolute value bar. Remember, that is multiplication with parentheses. So we have to first isolate these. So now we divide by negative 4. This, just like on the other two problems, flips the inequality to a greater than or equal to sign. And then this is equal to 2. So this is the absolute value of x plus 5 is greater than 2. So when we get the bars by themselves, we make sure that's even a possibility. Remember, absolute values are positive numbers. So we just ask ourselves, are there positive numbers that are greater than 2? Of course there are. So we're going to find out what these are. So what we have to do now is set up two separate equations. We're going to set up a alternate equation. We don't change the x plus 5. It's x plus 5 and x plus 5. But we're going to set up an alternate to this. So that would be a less than or equal to, and we are going to change that to a 2. So you see we reverse both of those things. And then we are going to do the exact same thing, which is a greater than 2. So here we have a one-step equation, so we're just going to subtract 5. So one of our solutions is negative 7. Now a lot of people are like, well, we can't have negative solutions. Well, we can't have negatives equal to the absolute value bar. But when we plug in negative 7, you see negative 7 plus 5 would be negative 2. But once you take the absolute value, it's going to turn back to a 2. And then on the last one, you should always be doing the same steps, by the way. Subtract 5, excuse me, I'm working ahead in my head. So when I subtract 5 away from positive 2, we've got another negative answer. So this is our lower value, less than negative 7. So what I like to do, I don't draw a whole number line. We just put our values on the number line. So this is telling me equal to 7, which is a bold circle. And this says equal to negative 3, which is a bold circle. Now, absolute values are always going to do one of two things. They're either going to have shaped like a barbell here, or they're going to be opposite rays. I guess I'm wrong. There's also a no solution. But it's going to look like these, or it's a no solution. So in this case, it says values less than negative 7. So we would go here. And values greater than negative 3, which would be here. Another option you could take is to plug in 0. So you see 0 on a number line is going to be somewhere over here, which would be part of the shaded. So 0, when plugged in, should work. All right, next thing we're going to look at is quadratics. The next two are kind of our trickier too, so make sure you're paying attention on these. Desmos, again, will make this a lot easier, so will your normal graphing calculator. But regardless of what you do, what we want to get is everything to one side. So we're going to move these two over to the other side, and I'm going to also shift over a little bit here. So we get negative 2x minus 158. Whoops, no I don't. Not yet. I have to subtract the 136x, and then I'm going to also subtract the 2. So this would be negative 136x, and these two combine to make negative 160. And all these values should be less than or equal to 0. Now, if you'll notice, all of these values are divisible by 2. So since this is an equation, I can just divide everything by negative 2. And that includes the other side. So after we divide here, we have x squared plus 18x plus 80. And we're going to see where it's equal to 0, because we got to test these values, because this could be shaped a number of different ways. So as we factor this, there are factors of 80 that can become 18. That would be both 8 and 10. So that means we would have solutions at negative 8, and we would have a solution at negative 10. So what we do at this point is we take it to a number line, just like you see, and we plot these points. There's negative 10 right there, and there is negative 8. And we're going to see where we should shade. Now, this was a greater than or less than equal to sign, so we know that these are going to be bolded in circles, just like you see there. So we need to either test these values or graph. A lot of times we just want to graph these things. But let's just take a look at the original equation. You could have gone any equation, by the way, but the original equation, negative 2x, let's plug in the number 0. 0 is somewhere over here, so if this works, we'll shade this way. If it doesn't work, we'll shade the other way. So we plug in 0, so this becomes 36 times 0, of course, becomes 0 plus 2. So this cancels, so the question is negative 158 less than 2? Well, yes, it is. So 0 is part of the shaded region, so we would shade just like you see there. So x would be greater than or equal to negative 8. Now, for time's sake, we're not going to plug in for the others, but we would plug in a value less than negative 10, negative 12, whatever the case may be, and just see if our values ring true, and they actually do. So our values will be values less than or equal to negative 10. All right, and the last little one we have here, first of all, I know this is going to have open circles because there is no equal to sign involved here. So that's good to know going into these. Might save you some time, especially if you're doing multiple choice. First thing we need to do is factor this numerator, because we got to find out where this thing is actually equal to 0. So we factor our numerator, and we get x factors of 15 that can become 2, 5, and 3. So it would be x plus 5 and x minus 3. So we refactor it this way. The thing about rationals, though, we have values, and again, this is much easier graphing. We'll show the graphing as well. We have values here that matter. We have an excluded value, and we have 2 zeros. So our 0 values are going to be x equal to negative 5 and x equal to positive 3. And then we also have an excluded value at x equal to 1. So this graph is going to change based on where these values are. So first off, here's -5. Next one on the list would be 1. And then the next one would be 3. So what we need to do, and it's actually really easy on this because we just need to look at the signs. We can plug in the values and see, but it's much easier to plug in the signs. I'll show you what I mean. So when I plug in 0, if this is a positive, because remember, we're looking for this value to be greater than or less than 0. That would be negative numbers. Greater than 0 would be positive numbers. So when I plug in 0 to this equation, let's see what we get. If I plug in 0, what I get is 5. And really, I don't even need to put 5. I can just put positive number. When I plug in 0, I'm going to get a positive number. When I plug in 0 here, 0 minus 3 is going to give me a negative number. And when I plug in 0 here, it's going to give me a negative number. So if I have a positive times a negative, that would be negative. And then divided by a negative would turn it back to positive. So the values that are between -5 and 1, like the value 0, are going to be values that are greater than 0. So that's not part of the solution. Because remember, values less than 0 are negative, just because that gives us out to a positive. We'll do this next one in a different color here. So pick a value, less than -5. Well, why not -10? So -10 plus 5 would give me a negative number. Oops, sorry. -10 plus 5 would give me a negative number. -10 minus 3 is going to give me another negative number. And -10 minus 1 is going to give me another negative number. So we have a negative times a negative, which is positive, divided by a negative would turn it back to negative. So this value, a value less than -5, was less than 0. So that's one of our solutions. X can be less than -5. X can be less than -5. The way we write this in interval notations is -infinity all the way up to -5, but not including. So we put a little parentheses there. Now we need to check between 1 and 3. Well, the obvious answer on that is to plug in the number 2. So let's do a different color here. Let's go with red. So let's do 2. 2 plus 5 is 7, which is positive. 2 minus 3 is -1, which is negative. And 2 minus 1 is also positive. So a positive times a negative divided by a positive is going to give us a negative solution, which is what we're looking for. So our second solution set is x values between 1 and -3. The way we write this in interval notation, not -3, I'm sorry, just 3. The way we write this in interval notation is the lowest entry is 1, the highest entry is 3. Since it doesn't have an equal sign, we use parentheses, not brackets. And then it's this U type symbol. Now we got to just test the last one, which would be a value greater than 3. So let's do this in blue, even though we already have a blue. Well, let's plug in the number 5. Why not? 5 plus 5 is 10, so that goes there, positive. 5 plus 3 is also positive. And 5 minus 1 is still positive. So positive times positive divided by positive is positive, but we only want values lower than 0. So that is not one of those. So our solution would be that. We're going to talk about graphing right now. Graphing is also not also, it is just generally a better way of doing these.